This is Software Engineering Radio, the podcast for professional developers, on the web at se-radio.net. SE Radio brings you relevant and detailed discussions of software engineering topics at least once a month. SE Radio is brought to you by IEEE Software Magazine, online at computer.org/software.
This is Sven Johann for Software Engineering Radio. Today I have with me Bill Curtis, who is the Chief Scientist of CAST Software and Director of the Consortium for IT Software Quality. He's best known for leading the development of CMM and People CMM at the Software Engineering Institute. In 2007, he was elected a Fellow of the IEEE. Today I will be talking with Bill about software quality. Bill, welcome to the show.
Thank you.
Did I forget to mention anything about you?
No, that's pretty good.
Okay, we're here in wonderful Dagstuhl Castle. I think it's the first interview we do in a castle, right?
Yes.
That's pretty cool. Okay, what is software quality?
I mean, a simple definition that kind of fits with the way people normally think about quality. We have a system that does what people expect it to do and behaves in ways people expect it to behave and meets the requirements and needs of the users. But traditionally, we've described it in a way it sounds more like the functional requirements. It does the things the users want to do. And the biggest problem is the users never state non-functional requirements. They assume you know those things because you're a professional. So they don't tell you that you shouldn't have SQL injection opportunities and you shouldn't have buffer overflows and you should handle errors properly and all this. And if you don't do those things and the system behaves in ways that the user suddenly doesn't expect, it fails, people break in and steal proprietary information, the performance degrades or what have you. And the user expects you to know those things. And so for the system to continue to behave in ways that meet the user's need and meet the user's expectations and satisfy the requirements, you really need to have this professional engineering knowledge about software so you build it properly. It meets the functional requirements, it does what it's supposed to, but it does it in a way that continues to support proper use of the system and proper delivery of the service the system offers to the users.
Okay, what are famous projects which failed to address non-functional?
Well, a lot of people right now know about the Obamacare mess, certainly in the United States, where the Obamacare system was brought online on October 1, and people were supposed to get on it and order insurance, because every American was now required by law to have insurance. And people logged on and nothing happened. I mean, they just sat there waiting. It was like waiting for Godot. And what happened? The system just not working. And what we found out is that the people who had built it really didn't understand how you build web-based systems. And they just downloaded every possible thing that a user might want any point in their lives. And it just swallowed up all the bandwidth. I mean, it's just really badly designed user interface.
But how did they get the project in the first place?
Well, the problem was that once they got the law passed, they had to go build it. But the Obama administration didn't want to build it too quickly because they wanted to get past the election so the Republicans couldn't use it as an issue and kill it. And so they started late, and they kept adding things and changing requirements late into development, and they got down to where they had actually 2 weeks to test the system. And this is a massive system that integrates, insurance companies with federal information about what you qualify for, and it was an enormous system, and they had 2 weeks to test it. So it was a complete disaster, and they could never simulate, thousands of people getting on this, or hundreds of thousands of people trying to get on this thing at the same time. And so as experts looked at, they realized they're just trying to pass too much stuff through the internet, and they don't need all that. The users had a basic set of things they needed, and other things they could call for later. And in looking at the system, we actually could look at some of the code that was the JavaScript and whatnot, and we found a security hole in the thing. And so we sent a little email very quietly and privately to the people that were in charge of these things down in Washington, and said, here's a little problem. It's known to be a potential security issue, and you may want to fix it. And they did, and a week later it was fixed. And in doing it, they added in an even larger security problem. So they basically had people that didn't know how to build these kinds of interfaces. And to get it fixed, the Obama administration went back to the folks that had built their websites for getting donations during the political campaigns, who did a pretty good job, but even they couldn't fix this one. So they finally went to Google and got Google to send some of their absolutely top geniuses in to come in, and they finally got the thing fixed because they were the gurus, right? So that was a classic one that everybody in the country saw. It was on the news. I was on TV 4 times trying to explain what had happened and why and what they could fix and all of this. So it was a major embarrassment, not only nationally, it made the world news. But another one I was involved in was back in my days with ITT in the early 80s, when they were the world's 5th largest company. And half the company was telecom and half was a number of other businesses. And if you remember, back in the early 80s, and most of the folks that are probably listening weren't even born then, but that's about the time we were moving from analog systems into digital systems. Everything was starting to move over to computers, microprocessors, and what have you. And so ITT just committed the entire telecom business to microprocessors, to move out of relays and into a digital world. And so they wanted one architecture they could deliver anywhere in the world, as opposed to having separate national units, each of which would build its own switch for its own country. We would have one generic switch with a generic architecture that, with minor modifications, we could deliver to meet any country's particular telecommunication needs. And so they charged ahead on this thing. They hired an absolutely brilliant system architect that understood these kinds of systems and had designed one. And in fact, they had to negotiate with the Swedish government, we heard, because he was declared a national resource in Sweden. But they finally got him.
Someone from
Ericsson, of course.
Okay, yeah.
And he was a brilliant guy. I mean, absolutely brilliant. And he had this beautiful architecture, and it basically, it took a telecom system and broke it up into independent components that could sit on different chips and interact through messages, and actually
sounds like microservices.
It sounds like microservices today. Yeah, there's nothing new in the atmosphere, is there? But anyway, so. They started building this thing, but the problem was those were 8086 class chips. I mean, they didn't have big memories and they didn't have big processors. And for the initial design, it was fine, but they kept adding on more and more stuff. They wanted this to be the ultimate telecom system that could do everything you could ever think of, years into the future. And so the functionality started exploding. They went from like a basic 45 or 50 messages up to like 450 to 500 messages. I mean, a factor of 10 growth and the bandwidth between these things. And the code was growing and growing. And when they started trying to integrate the system, you could just see the code flow over the sides of the chip and onto the floor. And so they were in trouble, and they knew it. And 3 months before the first competition, which was going to be in Stuttgart to win the German market, because we were competing with a number of other companies, they asked me to go to Europe and, because I was the measurements guy, collect some data and come back and tell us if we have a system to deliver in 3 months, right? So, I could kind of basically spell telephony at that point, but I wasn't going to be able to go in the architecture and figure out. So I went over there and I started looking through the data, and the data was a mess. I mean, it was just incomplete, and it made no sense.
Which data?
Management data.
Okay.
And I'll tell you this why, because there was nothing I could find that would give me any progress report. So I said, well, I'll look at the system integration.
So nobody knew about the state of the project. It was
some people knew. They just weren't telling anybody. I'll tell you more about that in a minute. So basically, what I saw was the amount of code being poured into integration tests was just going up exponentially. I mean, they were just shoveling modules into integration test. And as I said, well, let me just lay out what's going in and what's going out and the rate and all that. And there were all these module numbers going into integration test, and they never came out. And there were all these module numbers coming out of integration test, but they never went in. In fact, there were twice as many of them. I said, what on earth is going on here? Right? And then we found, oh my God, they're re-architecting the entire system in the middle of integration test because they finally realized the code's too big to fit on the chips. They now got to carve the system up and redistribute things across all these different chips. Well, they lost control of the generic architecture completely.
Yeah, but why did something like this happen? I mean, if you say
because they weren't measuring the size of the load modules. They weren't measuring the size of what they were creating after they compiled the code. And so this, it was just, just blowing up on them. And so all the German market required, all the German authority required was plain old telephone service. Well, we had all this other stuff on top of it for every future capability you could dream of. So over-engineering, it was absolute gold plating the thing. And the the fellow that ran our German unit, because earlier in the earlier years, we had national units in each country, and that unit would service that country and build a switch for that country. But now the theory was we will have one switch globally, one architecture that will serve all national governments, and you can then just basically adapt that architecture and make modifications to meet the local requirements.
Sort of a product line.
Yes, exactly. It's a product line, right? And just tailor it to meet, add some few things on, or take some things off, or whatever. And so that was the theory. Well, the theory was now blown to shreds because we'd lost the control of the generic architecture, and thus was split up all over the place. But when it came time to deliver in Stuttgart, and we rolled in a couple of small racks of microprocessors, and our competitors were bringing in, these big hunks of relays, large relay things, and it was a nightmare. And the system worked. I mean, the problem was we realized, the amount of code being dumped in the integration test was going up exponentially, and the amount of code coming out was absolutely linear. And so it was clear to me, we're strictly limited by the number of people that we have in the German facility fixing defects. Right, so basically, the senior executives at ITC said, okay, every man, woman, and child in the United States who can write Chill goes to Stuttgart and fixes defects until delivery day, till May 1.
Chill is a programming
Chill was a programming language in telecom. Okay. It was an object-oriented language, kind of like C++ back there, but
I remember Frank talking about it.
Yeah, so at any rate, we mailed a lot of people over there, and they stayed there for months fixing defects, and the system worked. The day we delivered it, the thing worked. It did plain old telephone service. They cut it into live traffic, and they never took it out because it worked so well. So we won the market, and that was great. And everybody was thrilled. We had big parties, got roaring drunk. And then we won another market. I think we won Mexico and Italy and China and several others. And all of a sudden we realized, oh my gosh, we've lost the control of the generic architecture. And now the cost of modifying the system to meet each set of national requirements exceeds the profit. We're out of business. Mm-hmm. And it came down, they had to win 45% of the American market against ESS number 5 from AT&T to even survive. And the architecture was such a mess at this point that they couldn't get it fixed in time. And ESS number 5 locked up the American market, and ITT was basically done. And so they sold the system off to Alcatel. Well, all the R&D money was already spent now, so Alcatel made money on it, because it was already developed. They kind of had it working. But it was a major problem, and they weren't measuring. They weren't measuring size. They weren't measuring a number of other things. They weren't reporting management results. But here's the story on the management aspects. Nobody in New York, which is headquarters for ITT, knew what was going on. That's why they sent me over. They didn't know if they had a system to deliver, right? And I couldn't find any data that would tell me anything. And so I'm sitting in this office that they put me in. Any data, you mean? Any data on progress. Project. Yeah. How far, what kind of progress are we making? And I'm just sitting there and wondering what on earth is going on. I'm in this office at the end of this hall. There's not many people in that hall. And I said, this data is garbage. I might as well just go look at the garbage in the trash can, And so I was just so frustrated. It was just so I just started digging through the trash can. I wonder what they throw away over here. Lo and behold, it's the project manager report for European development centers. Sorry? It was the project manager's report for European development centers, a report they made sure never went to New York because they didn't want the execs from New York coming over and bothering them. Right, and this had the progress report. It had all the progress. How much code was going in. The linear coming out.
But you could trust that
because it was only shared among the European managers at the development centers. It was not. They would not allow it to go to anyone else. Okay. It was their private report, so they could track it, but they wouldn't let anybody in New York know, or headquarters, or European headquarters, or anywhere else. And lo and behold, that's where I figured out what was going on. Looking at that, but the problem was they basically, in losing control of the architecture, they lost control of the company. They had to sell their whole telecom business off, cut the company in half because they weren't measuring simple things like the size of the load modules. Okay,
yeah, I mean it's interesting that. It should be clear that if you don't have quality, it's embarrassing. You're on television. You're on the front page of the New York Times, or even worse, you go out of business.
Yeah, well, and that's happened.
And when I talk to people and about projects with bad quality, usually the first thing is they say, let's do more testing. But obviously, I mean,
you can't.
Testing is not enough.
Here's a short story. The worst one most recently was Night Trading in New York. It's a high-speed stock trading company. down on Wall Street. And they were upgrading a system, putting the new release in, and all of a sudden it activated a lot of dead code. And dead code's code you thought nothing could reach and you don't need it anymore and you should take it out of the system, but they just left it there. What the heck? Technical debt, right? And all of a sudden this new version somehow activated the dead code, and it made $430 million of bad trades within 30 minutes, and they were bankrupt. Out of business, 30 minutes out of business.
Wow.
Yeah, that's so, and then you get a lot of these hacks you hear about now. The Heartland, which in the U.S. was SQL injection. We've known about SQL injection since the late 90s. How can these things be in the systems? Why don't they? We really need, for especially in security and things like that, where we know about certain kinds of violations and weaknesses. Why don't we have the same kind of effort we had with Y2K? We have to get that out of the system or everything will fail. Well, if we have to get these out of the system, or the hackers will take all your credit card numbers, and then they'll be evenly distributed over the provinces of Russia.
So I mean, what can we do, or what can these companies do?
Number one, they've got to
improve quality.
Yeah,
or
number one,
make things
they
work.
have to.
Yeah.
There's a number of things they have to do, and I'm going to go back to some other things in a minute. But they have to look at the architecture up front. You can't refactor a bad architecture. You can throw it out, and that's the smart thing to do. But the notion that it's going to emerge and you can refactor it, in the case of large systems, is just nonsense. It doesn't happen that way. And we found actually the highest quality is in systems where the method used to develop them was a hybrid between sort of a traditional waterfall up-front approach and an agile approach out back, where they're building and testing and building and testing and building and testing, so they get rapid feedback on the quality of the implementation. We get the architecture right, not complete, but we know we're on the right path with it, and we're not likely to buy the farm later. And then we have the rapid sprint implementations where we're testing it to know, okay, is the code we're building good code? Does it meet the requirements, etc. That seems to give the highest structural quality.
I heard a while back an interview with, I forgot his name, but he's deeply involved in the Agile community, and he said, the Agile community did a little disservice to the rest of the community by not focusing on architecture, or not enough focusing on architecture, because you cannot refactor properties in the end. So
and you need
a decent.
You get the real leaders in that community, guys like Scott Amber, and they're absolutely clear. You need a sprint zero, and it could be of some substantial length, where you really get to a point where you're comfortable, you're on the right track with the architecture, and then you start the rapid, 3-week, 4-week, whatever sprints to get the code built. But and that works. We've got hard data on analyzing systems that shows that that's the best approach when in terms of structural quality. So now, what else can you do? The whole CMM was designed to solve a set of problems, and they were problems that were killing systems. If you remember back in the 80s, it was never on time. It was way over budget, and it half the time didn't work when you got there, or it was riddled with defects. And a lot of us thought, well, we just need better languages and better tools, and that's what we were working on. And one fellow said, no, you're all wrong. That is not the problem. You will not solve anything with better languages and better tools until you get management under control. And of course, that was Watts Humphrey. And Watts said, look, the problem is that when executives or project managers come up with schedules that can't possibly be achieved, then the developers just start having to work at breakneck pace. They barely have time to get the code written. They don't have time to evaluate it or test it. And so they're just cranking out garbage, and they know it, and they're frustrated, and they don't feel like they can work like a professional. And they can't, because you never gave them the time to do it right. And so the level 2 in the CMM was designed to get control of commitments and baselines. So and if you don't do that, the quality is going to be terrible.
Okay, but what is CMM? Maybe not everybody.
Capability Maturity Model was a model developed at the Software Engineering Institute at Carnegie Mellon to help an organization improve their process in several stages that continued to build, a world-class software development organization. But it was done in stages, and the first stage was you must stabilize the projects. You can't have organizational level you have to do, everybody has to do this. It's not going to work if the projects aren't stable. If guys are working at breakneck pace and not having time to properly design or properly test the code.
So a stable project is a project where...
Two things. It has commitments that it believes it can meet,
Okay.
And it controls the baselines. It has control of the requirements baseline and control of the product baseline. Now, it doesn't mean you can't make changes, but you then go back and say, okay, does this affect schedule, or our cost or whatever, and you make adjustments, and you can add people, or you can cut functionality, or and whatever you need to do, but you don't want people working at a schedule they can't achieve, because they'll never have time to do work in a professional way. And that was the first thing we had to fix, and that's a local fix at the project level. So level 2 is about projects and getting people into an environment where they can behave like professionals. They have a fighting chance to do work in a professional way. Once you have the project stable, then you can look and see what practices are working best. This team has a great set of design practices. Those folks have some really good testing practices. Over here, they've got some good estimation practices. Let's integrate all this together into a common organizational way of doing it. And we can tailor it for big projects and small projects and new technology and legacy stuff and what have you. But the bottom line is we have a set of practices that we know in our environment work well, and we know how to tailor them to fit different situations. And then I really get an economy of scale. We have an organizational culture. It's a software culture, and when that happens, you see it's the developers that carry it, not the managers. It's the developers say, look, stop doing that because you're screwing up the way we build software, and it's just going to delay us, and it's going to mess up the system. So they will be the first ones to react when somebody starts violating good practices, because they already know what's going to happen when that takes place. So the developers really come to carry the culture, and there's a lot of pride in the quality of what they're producing. Quality goes up dramatically in this case. They know what it takes to do the work. They can make estimates that are reasonable. They know what it takes to control it, and they know what practices work well. So that's level 3, and then we can, higher up goes into sort of statistical management and other kinds of things, and innovation and whatnot. But we know that
does a higher level means a better organization?
It means a better organization if it's done right. And a lot of people knew where to buy a level 5, not really achieve it. They just want to, get the box checked. But the people that really go about it and really use statistics and measures as the way they manage the software. I mean, the truth is in the measures, and they use that to control what they're doing and adjust as they need to, adjust quality levels. That we've seen quality improve by 100-fold in higher maturity levels when it's done right, and when it's an end-to-end process that's managed with data on what's going on. They can adjust much earlier, and they learn how to tweak practices to work more effectively. And it's really much like lean, the lean concept.
Exactly. I was about to ask. It really sounds like
it's really statistical process control, but it's different because this is an intellectual artifact. Traditional lean and statistical process techniques were developed on manufacturing, where I'm doing exactly the same thing over and over and over and over, 100 times an hour. Software's not that. I never do the same thing twice. And so we have to think about how do we use data in an intellectual environment as opposed to a physical environment, because this is an intellectual artifact. And in truth, the measurement of intellectual artifacts like software or even text is in its infancy. I mean, we've tried a bunch of things, and sometimes it worked and sometimes it didn't. But there's a lot we don't know. And we used to think, well, we just measure the structure of a paragraph, for instance, back in the 50s, and that'll tell us how understandable it is. And then we found out that doesn't work, because how understandable it is depends mostly on how much you know about the topic. And that's not the structure. Right? And so that's why in an intellectual domain, this doesn't behave according to physical laws, and we have to understand measures as indicators, but not they're not absolute like a law of physics would be.
Exactly.
So, but you can do it properly and it'll work.
Yeah. Let's go back to the don't do it properly.
Yeah.
Because that sounds all fantastic, but when I studied, CMM had this negative.
Well, it does when it's done bad.
It's heavyweight, and
CMMI is.
You have to produce only documents.
Yeah, CMMI is too heavyweight. It's way overdone, and it's because they lost control of the architecture. The folks that built the CMM were not involved in building CMMI.
What's the difference between CMM and
CMMI? Well, they wanted to integrate systems and software, number one, because CMM was a software model, and the system engineers had their own, and they wanted to integrate both of those. And CMM was what's called a staged model. It basically builds the architecture, it builds the organization level by level. But the model is, this is how the organization works, right? And there's something called a continuous model, which is not an organizational model, it's a practice model. So it says, okay, the practice I care about is testing, so I'm going to take testing up to level 5. well, if you don't take design up to level 5,
Yeah,
right?
okay.
I can have, and it just said, just take the practices you're interested in and work on them. And it doesn't reflect trying to grow an organization as an organization. So you don't see the same culture change you see with CMM. CMM really fundamentally transforms the organization in a series of stages. It's stabilize, standardize, optimize, innovate. And you're basically taking, at level 2, it's about projects. It's almost a tribal sense. Each project has its own way of being stable. But then out of this, I have to build a common culture and a common process that works for our organization. And so now I'm kind of moving up to the level of a civilization. It's city-states becoming a country in a sense. And in doing that, you really get to a whole new level of the way the organization functions. And a great description of, doesn't take the CMM approach, but a description of how powerful this is in Jim Collins's books, Built to Last and Good to Great, where he talks about the power of really great organizations is in their system, in their process, in how they operate as a company, because they have a common way of doing it. Everybody understands it and buys in, and therefore the system operates very effectively. And that's what we're trying to get to with CMM. CMMI said those two models, the organizationally based stage model and the practice-based continuous model, were two representations of the same thing, and they aren't. They're theoretically not the same, and they're practically not the same. But to make those, kind of make them into the same model, they built this architecture that was way overdone. And so CMMI got huge because they basically didn't understand the theory and lost control of the architecture. And so there were all these practices, and it got very expensive to do the assessments. There was tremendous duplication of practices. And so ultimately people just said, no, we'll buy the book because there's a lot of good guidance in there, but we're not worried about doing the assessment and having to satisfy all these practices. And that was unfortunate. And I think hopefully with the next generation of CMMI, they'll bring it back to something that's more appropriate for most businesses. More lean is the issue here. We want something that's lean and really only includes the practices that you really must have.
Exactly. So that means you need to know all the best practices, and you need to understand which ones are important for your company. Yeah. So what are companies like Google or Netflix doing? Are they following the CMM ideas?
They're probably they would probably never tell you they're doing CMM or CMMI, and they wouldn't want to. But if you went in and looked at what they're doing, they're probably doing something very much like that.
Yeah, exactly. I mean, they don't have to say they are doing it, but probably they pick out.
The greatest piece of software ever built was Space Shuttle Avionics. It was probably the most elegant, beautiful, and high quality system ever created. And that was the model for what a level 5 was. I mean, they were incredible. I visited there and spent days down there, and I had never seen anything like it. But they would never, ever claim they were level 5. I mean, when I went down, I said, look, we know we're not level 5 because there's things we don't do. But this is what we do, and we know it works. And we know that when we deliver software to NASA, we believe there's no defects in there that can affect safety. Which means basically, since nobody knows what affects safety in space, because space is a bizarre place, it basically was defect. It was very close to defect-free. You couldn't prove it was defect-free, and every once in a while they'd find something. But in most of the stuff they were finding had been a defect entered 10 years before, because their process was very good at delivering very elegant code. But they would never claim to be level 5, but they were just rigorously doing these practices because they know it served their need, which is basically almost zero defect software. So, and really a company has to decide what's the level of quality we need. If I'm in telecom, I'm allowed a certain amount of downtime every year, and they're not going to pay me to go to zero. So I need to adjust my practices to get to that level, and then that's fine. That meets my business need. So that's really the critical issue here. And we do see, and there's a lot of data now, that the higher the maturity, if you're really doing it to improve the way you build software, defect rates go down dramatically, productivity goes up, people start being able to reuse stuff because they trust it now. They didn't do that before. So there's all kinds of advantages that we see when it's done right.
But I don't want to have the certification for CMM level 5 or VATS. I should look what are
look at that and see if it meets your needs. Yeah, see if it meets your needs, because we know that people who really implement a serious program like that have lower defect rates, and it costs less to build software. There's good data out there that says they're building it for fewer dollars per function point or per line of code or whatever your favorite measure is, because they're not wasting time. In a low maturity organization, 40% of the effort is spent on fixing mistakes. And the lean world, that's muda, right? It's waste.
Exactly.
And that, and what you want to do is eliminate the amount of waste you have, wasted time you have fixing mistakes. You want to catch them early and get them out of the system so that you're not spending 10 times more effort on the back end, undoing stuff and rebuilding stuff and reintegrating stuff and all that.
Especially architecture.
And you're dead meat if it's a critical part of the architecture, yeah.
Better Software East is the premier industry event for software professionals, covering the entire application lifecycle. Held in Orlando, Florida, this November 13th through 18th, Better Software East offers deep dives in topics including leadership, project management, mobile development, software design, and more. As an added bonus, the event is co-located with the Agile Dev and DevOps East conferences, and one registration automatically gives you access to all 3 programs to build a customized week of learning that fits you and your organization's specific needs. Explore the program at bsceast.techwell.com. SE Radio listeners receive up to $600 off with code SERadio when they register by the September 16th super early bird deadline at bsceast.techwell.com.
Yeah, but I think it's interesting that whatever method you invent, even if the first thing you read is you don't have to apply everything, just take the stuff which makes sense for you.
Well, but I would.
Most people ignore that and just
do
everything.
Here's the problem. Most people believed that before we had CMM, but they weren't doing the right stuff. They were believing all I have to do is have better design practices and better testing practices and better tools. And they didn't touch management because they were thinking about engineering. And they weren't thinking about the fact that we're doing a crummy job in engineering because we don't have the time to do it right. And until somebody said no, the first step is you must get control of management. You must control your commitments. You must control your baselines, right? And so you need guidance, and that's what CMM provided, was saying, look, these are the important elements you must have to solve this set of problems. And once that's solved, then here's the next set of problems. And so it organized an approach to solving problems, and it didn't let you leave out some of the critical parts. Which is why I'm no fan of the continuous model, because it lets you leave out critical parts. I could focus all on engineering and not focus on management, and I'm back to schedules I can't achieve.
So now you say there is a relation between CMM and Lean. So for me, it was always like CMM and Agile,
but not
very
it should be. But it should be. But the problem is the way CMMI worked and the assessment method worked. You had to have evidence you performed every single practice. That wasn't true in CMM. You had to achieve the goals in CMM, and we want to see, have you achieved the goals? These practices are guidelines for what you might do to achieve those goals. But if you've got a better way to do it, or you don't have to do all of it, and you achieve the objectives of the goals, then fine. But CMMI said every practice has to be right, and that's anti-lean, because lean would say it may be a good practice, but if it doesn't add value, then don't do it.
Yeah,
right?
Exactly.
And so the Scampi method that's where we got this butting heads with the lean concepts.
Okay. You mentioned the continuous model. So that is continuous delivery, DevOps. Is that,
no, not at all. Continuous just says I can pick any practice, design practice, and take it up and down the levels. I can go, if I want, I want to be level 5 in design, but I'm only going to stay at level 2 in management, right?
Okay.
And so it just says it's practice based. Everything is this practice and that practice, but it's not the organization.
Okay.
And the essence of the CMM, as we originally conceived it, the stage model, it's an organizational transformation. And I'm using I'm integrating these collection of processes to fundamentally change the way the organization works. It's not about design or about planning. It's about getting a management infrastructure in place that doesn't make bad commitments, and it's able to control the baselines and control change so it doesn't throw you into chaos, right? And then it's about getting things organized in a way I have a common way of doing it that I can tailor to different projects. But it's the organization's way of doing it. It's not I just have a good design technique or I have a good testing technique.
Okay.
So that's now, and so I'm not a fan personally of the continuous model. A lot of people are, I'm not. But if I were going to re-architect these things, I would split them. Because putting them together, the architecture you have to have just makes it a lot of duplication, a lot of excess that doesn't need to be there. So if you want a continuous model, have it, but don't try to force stage to fit with that in a common way. Because what happened is they took the stage model and way overburdened it with practices. There was duplication. So I would break them apart. And there's some additions and changes, but the basics are there. It's not in a bad situation, but I would certainly break them apart and change the architecture to reduce the duplication. I mean, they basically made a matrix. There's this set of practices and there's this set of practices. One's on the rows, one's on the column, and you have to fill in every cell. No good designer works that way. Everybody builds a matrix, fills in all the cells, and then says which cell is important, right? And if it's not a cell that's important,
what's on the matrix now?
Well, they have what they call specific practices on one axis, and those are the unique practices you would perform for management or design or testing or whatever. Then they have practices on the other axis, which they call generic practices, and those have to be applied to every single process area in order to institutionalize it. But so one of those is configuration control. Well, I've got a process area called configuration control. So now I'm sitting here saying I'm going to have configuration control on my configuration control. And when they got to level 4, it blew up. I'm going to have statistical process control of my statistical process control. That just didn't make any sense.
Yeah, okay.
So, I mean, the theory blew up, but they didn't do anything about it. And so I would just get rid of the generics. And because I know how to build all of that stuff into the basic model so you don't have redundancy. And it doesn't increase it that much. So it cuts the model by at least 40% and almost 50% in some cases in practices, and makes it much more conformant with the original intent that Watts had and that the design team and I had when we built the CMM.
Okay, so now if the US digital government would ask you to design, a new maturity model in times of DevOps and continuous delivery?
Well, you add those practices in, right? I mean, level 2 is about getting the project stable. So I'd want the DevOps operation, if that's going to be my process, to at least be properly estimated. And we understand what we're going to get done by when, so we can track, are we making progress, or are we not making progress at the right rate? And if we're not making progress, we're falling behind, and we need to take corrective action.
Okay.
I mean, it doesn't guarantee you're going to have your estimates are going to be right, but it does guarantee you'll know they weren't, so that you can take some corrective action. Maybe you cut functionality, maybe you extend the schedule or whatever. But you don't say, I'm going to deliver Obamacare on October 1 and only test it for 2 weeks.
Okay, but you would start with one project and then you try to stabilize that.
And then you move on to and you move it out across the organization project by project. It's not, I don't have to have the project one finished before, but I get these guys working on it, then I get the next guys, and I get the next. And what we found is the best way to do that is called project launch workshops. So up front, at the very beginning of the project, the consultants or whoever the experts are, if they're internal, that's fine. Work with the project to build a plan to understand. Do we have the requirements pretty well set, or are there a lot of things that haven't been stated we need to go back and ask them about? So let's make sure we understand what we're trying to do, or we've got good stories or whatever, and then we've got an estimate for how much work we can get done by such and such a date, if it's date constrained. If not, then we look at what we have to build and say, by when can we get this done? And you just basically have a plan that you can track. And if you're wrong, that's okay, but you'll learn from it. As long as you're tracking, you'll realize we way underestimated the amount of time it would take to do that. Next time, we make that adjustment, but we need to make a change in our plan. You deliver less functionality or extend the schedule or whatever.
But is it hard to convince companies to try that out? I mean,
no,
I see
not after a disaster.
Okay, but that's the problem.
Let me tell you. Here's how you do it.
One thing. I'm a consultant, and I just wonder if I have to wait until a big disaster happens.
You have to wait until the executive wants to make improvements. If the executives don't back it, it's not going to work. I mean, you have to have executive management to support to make the process improvement program work. And once you've got that, you're on your way, because they'll say, we are going to do these things. And managers that don't want to do these things will no longer be managers. Right? They have to be willing to remove managers who won't go on. And the successful ones do. And you see some people, continue on as managers because they understood what management was, and other guys who just wanted to have a good time end up doing something else. So that's critical. And then let's see, what was the other part of your question? You have to have management support. You roll it out in project by project. So these project launch workshops, really, and then whoever the consultant is comes back periodically and sort of, how are you doing? Are you having any issues, et cetera, et cetera. So you don't have to have a disaster. You just have to have an executive say, we need to get this under control. And I tell you, the way I've convinced them of the value of it is you'll talk about process, their eyes will glaze. You ask them one simple question: how many good project managers do you have? They just and they start counting their fingers and realize I don't even need one hand to count the good. If they're a low maturity organization, they suddenly realize they don't really have good managers in place, and these guys aren't trained. They probably never, they were just promoted because they were good coders. And you say, look, as you start this program, the first thing I'm going to give you is project management. These people will learn what it means to manage, to plan projects, to track projects, to take corrective actions, to work with their people. And what you will come out with is project managers who can deliver projects. Ultimately, they'll learn what it takes to do good estimating and deliver them on time. But and they suddenly say, okay, yeah, I get that. Because if they're executives, hopefully they've been successful at management, and they understand what they're not seeing and they need to see, and that really helps them convince themselves they need to launch this and enforce it.
Yeah, but it's probably not easy. I mean, even if you're convinced you need a better project management, where to find these guys.
Well, you're going to have to train them. You're going to have to find people with an orientation toward it. And it's not always the best programmers that have an orientation towards being managers. So that's part of it. So they'll be trained, and that's what the launch workshops do. You work with the putative manager to learn what it means to manage. Yeah, they learn how to build a plan. They learn how to evaluate requirements to make sure, they know what's complete, what's incomplete, and what they need to go back and ask about. They learn that they need to get some plan for configuration management. How are we going to control the configurations of this thing, and the versions and all that. And so they get that in place. Often there's early resistance from the developers, because you're going to put me in a straight jacket and make me march like a robot or something. And the thing to explain to the developers, listen, you're already in a straight jacket, and you are marching not like a robot, but like a crazy rabbit, because you've got schedules you can't achieve right. And they say, yeah. And they say, how much time do you have to sit down and really think through your design issues? None. I just got to get code out, right? And so they suddenly realize, if you can get control of this, I can act more like a professional. It's not about me to adhere to some idiotic process. It's basically freeing me up to engage in professional practice and follow a process that we know or were taught in grad school would actually work.
Probably it's also about, creating some awareness of these things, because what we see is architecture. A lot of people don't think about architecture, but if you do a workshop and you say, there you have to look at that, you have to get you have to think about all the LETs and things like that. And it's like, that's interesting.
So and so here's the other issues is that the next body of resistance comes from middle management. If you're in a big organization, because they've gotten to where they got, they're not project managers now, they're higher up, and they've gotten to where they are by whatever it is they were doing. They knew how to manage the relationships and push guys to work nights and weekends and bring in carry out pizza and all that. And now their whole way of existing is threatened. Right? I mean, they can't kind of use these motivational techniques anymore, and they sometimes feel like this is an invasion of their private domain and the way they want to run their
Why
business.
Is it threatened?
Because things are going to change below them, and there's an executive above who's putting pressure on them, and they don't really have complete control over what's going on below them, although they'll have a lot more control if they get good management in place. But a lot of them just have had a way to run their business that was, I gotta make these commitments, and I motivate people to meet them, and they're up here nights and weekends. But you can't do that anymore.
Yeah, but how does it work? Let's stick to the Google example. Because most people think that Google is.
I can't tell you how Google works internally because I've not been inside Google. I do know this. Several things go on. Number one, they have a common code tree, so they're all working against this common code tree. They hire really
against what?
Common code tree. I mean, it's where all the software.
They have one repository.
Yeah, and everybody works against it. They do buy some commercial tools from what we've heard, but they frankly build a lot of their own tools because they're way beyond what commercial tools can do, and their requirements for the tooling is just out there. I mean, the future of software engineering is being developed in companies like Google and Amazon and Microsoft and whatnot, because they really are at a level of usage. How many billions of people sign on to Google and Amazon and MSN and all this. And so they have stresses that nobody else has yet, but a lot of people will have. And so they're having to develop the tools to manage the way they go about this. They're having to build processes where they can update systems in flight. How do you repair an airplane when it's 35,000 feet in the air? Well, they've kind of learned to do that with software while they're in operation. And there's specific things they do, and they have rules about so there are processes that they have to pretty rigorously follow to be able to do the things they're doing at the scale they're doing it, and under the kind of performance pressure they're doing it.
Performance pressure.
Performance pressure is
innovation.
Performance pressure in the sense of when I get on Google, I want an answer. When I get on Amazon, I want to see the products, right?
Yeah.
And I don't want to wait 5 minutes. I'll go have a cup of coffee, come back and see if they figured out what my question was. So they have that kind of performance demand, which is extraordinary, right? And they've got these huge server farms and everything else to help manage that demand. But that itself is a body of infrastructure software that's really quite something. And they have to innovate because everybody's competing against each other. Those three are competing to see who's going to own the cloud. Everybody wants to now to be you use them as the cloud service, and so there's high competition, and they really do have to innovate, but at the same time they can't lose control of what they've got because we expect it to perform 24/7, 365 at almost microsecond speeds. So that requires that you really do have a very rigorous internal. They could care less about, I assume, about CMM, but if we went in there, we would probably find an awful lot of the practices they put in place wouldn't meet the requirements because they have to perform at that level. And they use measurements a lot. Google.
Yeah, I think that's really interesting. I mean, that's for me the bridge to software process improvement and things like that. That Google, I don't know, but Spotify, they measure basically everything.
Yeah.
There is everything. There is a measure for everything. They don't do anything. They don't put anything a little bit further if they don't have the data that prove that a little thing works. And
absolutely. And the whole concept of lean startup is get data on what works and what people want, and then go down that path. Cut off this path that they didn't care about. So there's they really do have to be constantly innovating just to compete with the other guys that are constantly innovating. And so that's a high maturity. Level 5 is about constant innovation. Having a standard process, you can bring that back into an update, and then learn what the new measures are. Have what the new thresholds and baselines and all that are. So this is it's pretty sophisticated stuff, and the maturity model gives you a good guide for how to get there. And doing it because you want the certification is not the reason. Do it because you want to compete like the Dickens. I mean, you really want to get to where you're able to innovate, you're able to compete at a very high level. You're not wasting a lot of time on fixing defects and trying to refactor architectures that you shouldn't have to refactor and that sort of thing. Exactly. So that's the objective with this.
Follow processes.
And one thing I'd recommend people look at is watch Humphrey's team software process, because the data on that is extraordinary. It basically says, as a developer, I want to develop myself the way an athlete would develop them. Athletes, everything's measurement. I mean, they measure everything they do. And so what Watts said is, if people would just measure how they make mistakes, how long it takes to do things, their own personal process, and then as they get together in a team, they can say, this is what I can do, this is what I can't, and the team makes better commitments, and they start learning at a much faster rate. They learn why they make mistakes, so they avoid that in the future. The data on the team software process is absolutely extraordinary in terms of quality levels and productivity levels.
Yeah, I can imagine. I mean, I only read the book on the personal software process.
Yeah.
That was already pretty interesting because they said stuff like, okay, please check how you work. How if you go to the toilet, make a note. If somebody asks you something, make a note. But what it showed to me was, I rarely work more than 20 minutes concentrated on something. And then it's like, okay, once you have the awareness...
Not everybody goes the extent that Watts does. Watts was a unique individual. Watts had statistical process control over how he balanced his checkbook. He literally measured how long it took, how many mistakes he made, how long it took to fix them, and he got to where he never made mistakes balancing his checkbook. He knew exactly how many pennies he had. He was an extraordinary individual. Not everybody has to get to that level, but if you want to be a truly great software engineer, you need to know what you're able to do so you can spot the weaknesses in your own personal way of doing software development and correct it, and learn why you make certain kind of mistakes and correct that.
And as a team, I mean, I know that Spotify, they have their squads, and they have all kinds of measures on their squads, which means and measures on everything. Like what is the value, the customer value they produce. But
and that's how sports teams work.
What's the bridge to the team software process?
The team is I need to know my data before I can tell you integrate with your data. I need to know how I perform before I can tell you what I can do and what I can't do, and how we coordinate. If I come into the team launch meeting and we're trying to figure out how much can we get done and in a reasonable amount of time, what are our commitments, we each have to be reasonable about what we can get done, because traditionally, the smart guy in the room would say, well, I'll do that, oh yeah, and I'll do that, and I'll do that, and I'll do that, and they would get grossly overloaded, and they would become a bottleneck, and the team would slow down because nobody else could get stuff done because they're waiting on this guy to finish stuff, and it becomes a mess. And so what this is, each person needs to know what they can reasonably expect to get done in a reasonable length of time without working nights and weekends and all that, and not overload themselves, but spread the work across the team so the team can perform at a sustainable level, and make commitments that they believe they can meet, and then they can learn why they didn't meet them. Right? If I've got the data, I know, okay, I overestimated this because I forgot I had to do this little thing, and so it becomes much more disciplined.
So when I had my first extreme programming and Scrum project, exactly these things happened. So basically Scrum follows these practices.
Scrum, when done properly, is very powerful.
What is Scrum done?
Well, I remember seeing Sutherland, who's one of the developers of Scrum, at one of the Agile Alliance conferences, and he stood up and he was given a sort of a long session. In the middle of it, he said, 70% of the companies I visit are doing Scrum, but. I said, what? Said, we're doing Scrum, but we don't hold daily stand-ups, but we don't do daily bills, but we don't. No, they're not doing Scrum. All right, they're doing Scrum, but so they're not truly agile. They're not doing the method. It's just undisciplined hacking, and too much of what was called agile, people just use that as an excuse to kind of do what they wanted to do. Whereas Scrum is a disciplined method, and if you do it properly, you'll get very good results. And a number of the other agile methods are that way. The various crystal methods. That I would say Alistair
Coburn.
Yeah, Alistair Coburn developed. His concept was you can't apply the same method to every type of project. Huge projects are going to be different because you got multiple teams and all. So he adjusted the practices in each level of the method to work with the kind of organization, the kind of challenge you're facing in that kind of project. And so he adjusted it. He tailored the process to fit the nature of the project. That had a very good sense in that. There was a lot of good thinking by some of the top guys that went into the thinking about what a truly agile program is. The one thing they threw out that was, in many cases, that was a very powerful practice, I mean, the data is absolutely clear on this, is one of the best practices in software engineering, was formal inspections. It is remarkable its ability to capture and remove, defects very early. And
formal inspections in sense of pair programming, code.
No. Pair programming is not formal inspections. Formal inspections is, I've built my component or I've designed my component. I want 2 or 3 other people to review it. And that means by formal inspection, they will go off and spend time to review it, and then we'll have an inspection meeting where they'll come back and say, these are the things we found, right? Okay. And so I may have one guy looking for security problems and one guy looking for functional problems, and so different people take different perspectives to make sure. And it was incredibly powerful. That's gone because you can't. That's not going to work necessarily in these 3-week cycles. The 3-week cycles you'd have on a Scrum or 4-week cycles in a sprint, in a single sprint, right? And so one of the things that can replace that if it's done well is structural analysis, is static analysis and maybe some dynamic analysis. Because if you can really do analysis on the system as built, not just the code units with an IDE tool, but really look at integration time and integrate the software and then run a static analysis at the system level. You found that at the code level, you found code problems. At the system level, you found system problems. And many of these are the same problems you would have found in a formal inspection. So if you can use more the advanced tools that are out there now for static analysis, dynamic analysis, behavioral emulation, some of these other things, you'll gain back some of the power that was lost when formal inspections were dropped. So there are things that can make Agile very powerful because you do have much faster feedback, which is critical. And if teams have time to take the feedback and absorb it and then make their decisions about what they're going to do about it, what's wrong with the system, they learn. They learn about parts of the system they didn't know about before. They learn about assumptions they had that weren't correct. They learn about certain kind of structural issues that were inefficient, and that just makes them a much more powerful team.
But usually I should always do some sort of inspection. I mean, I could imagine when I collect the requirements, then somebody should.
It'd be a really good. It would be a really good idea to have some kind of formal inspection to make sure what are these complete. Have some of them been left so fuzzy that we really don't know what it is? And the same thing with stories are not necessarily requirements. They're like requirements, but they're not exactly requirements, right? Mm-hmm. And so if I'm going to live off stories, I need to understand what assumptions are being made that aren't being stated. What are the aspects of this system that you're not going to get by reading a story, by getting a scenario, and that needs to be thought out. So that you don't go down the wrong path with the architecture or whatever.
Exactly. Yeah. But my problem with inspections, my problem with inspection is it's already too late. When I have to do a larger review, I'm like, oh God, so many details. I just don't know anything about it. Lots of things get lost. So I'm just wondering if it's a healthy back and forth of.
It is if it's done on a rigorous. In a well-run waterfall, the agile world has always reacted against a waterfall saying it's a bunch of garbage. The finest software ever built was built with the software. And the Space Shuttle Avionics software, the best stuff ever built, was a rigorous Space Shuttle Avionics system. And it's probably the prettiest piece of software ever. It was built with a rigorous top-down. I would say top-down. It was built with a rigorous waterfall model.
But
most
it depends on.
Hold on. Okay. Most people aren't doing waterfall with any discipline or rigor. They just get some idiotic date thrown at them and say, go build it. And there's really not the discipline required. It wasn't the waterfall. It was the bad management and the poor discipline that led to a mess. And they said, look, if we could at least get faster feedback. Because number one, the customer doesn't know what they want. And so I really need to be able to give them a piece of the system, a prototype, if you will, get them to react to it, and then I'll build it. If they like it, then we can build the next piece on top of that. But I want to give them something that works, that they can look at, they can decide, okay, what do you want next? What stories make sense to you? And so there was that aspect. And the rule in the space shuttle was, okay, we build prototypes all the time. NASA wasn't sure about the requirements. We built a prototype, they'd react to it. But the rule was we throw out the prototype because it was not built with a level 5 process. And it probably contains defects we don't even understand.
Okay, so the prototype just verified.
It was just to get the requirements straight, to get the customer.
Okay.
Now the problem
requirements straight, or also requirements and prototype to prove non-functional.
But you probably wouldn't prove the non-functional with the prototype. You wouldn't prove the non-functional necessarily with the prototype unless you were aimed at trying to figure a certain structural problem out, right? Because you're not building it to be structurally strong. You're building it to demonstrate functionality to get the user to react. One of the problems we've got that I think I've seen with Agile is that the goal is I want to respond to the customer. I want to be agile so as they learn more about what they want in their system, I have the ability then to change directions and get it more to what the customer really wants. Well, the problem is, what if the customer doesn't, we assume they don't always know what they want, but here's the worst case. The worst case is going to a bank. How do banks grow? They grow by buying other banks. Right? And each bank has its own process and its own way of doing things, and they don't want to change. And so if my representative of the Agile team is you and you're from Division A, you don't care what Division B wants, and Division B is not going to want necessarily all the things you wanted. And so I'm just getting your view. But there may be, if I've got 20 different banks that have been acquired and they all want a different way of doing it, now all of a sudden the requirements get massively complex. Some of them conflict. And so I can't constantly respond to whatever user tells me. And so I've got to be able to do all this stuff because that's what the user is requiring. In some case, somebody has to put adult supervision on the business and say, folks, we have got to have a common business process here. Because the IT systems we're going to create are going to be monstrosities. And they're going to be impossible to maintain. And we will not be one bank. We'll continue to be 30 different banks. There's no economy of scale. And we'll never get the ROI.
Somebody has to do it, but mostly this person doesn't show up, right?
Exactly. So the bottom line is part of what Agile needs to do is when they really do start getting a lot of stories from different people that are conflicting, and it's just clear there's a lot of different processes out there, is say, look, you need to go straighten out your business process and get some consistency here, or else we're going to build a monstrosity. We can't continue to respond to you if you're telling us 87 things. We actually did an analysis in the bank one time, and every brilliant guy, famous computer scientist, do it, and they had 183 processes for their credit card division, and like they had 18 different ways to open an account, one for every different credit card company that they serviced, right? And by the time he was finished, he only spent 2 months, and he'd cut it down to 53 processes and 3 ways to open an account, Right? He just went through and said, these are, there's a lot, everybody has a little bit different, but basically here's the generics. And, get down to these basics, and then you can have small variants on it. And it just cut their process down to much, much simpler, made it much more understandable to the people that had to do the work. And the IT system then could be much, much simpler.
So that leads me to one question I discovered these days here was that 20% of the defects come from bad code or something, and 80 come from bad requirements. So
that number varies based on which study you look at, but there's a large number of problems that come out of bad requirements. It's requirements that weren't stated completely or were fuzzy and whatnot. But Laura, it's a lot of that. They just didn't state a requirement, and then there was a defect. There was what was called a defect because it didn't do something the user wanted.
Okay. So I know.
Right?
I know. It's like, this is a bug. No, it's not a bug.
There were conflicting requirements. One person said this, another person said that, and they weren't the same. And it was never worked out, and so now the system's got this problem.
How do I fix?
You get them to sit down and work it out until they come to an agreement on what has to be the way the system works.
Yeah, but
you shouldn't make that decision as an IT person or as a developer. It's not your responsibility. It's theirs, and we've got to stop taking the blame in software development for problems a business has and getting their business straight and getting their business process simplified and organized, and not trying to have 87 different ways to do everything and then expect us to build that into a clean, easy to maintain IT system. It's just not going to happen.
Okay, so basically when I discover a problem,
you need to go back to the customer. You need to go back to the customer and say, look, here's a problem. I can add these 87 features, but it seems to me there's only a basic set of 20 here, and this will be massively complex for you and me if we don't, or here you said this and you said that, and that leads to just completely different algorithms or something.
But from a contract point of view, I mean, I've been in this situation quite often where I said, hey, look, this makes all no sense, and then the answer was like, okay, but we have fixed requirements, just do it, and when you're done, we make new requirements to build it out, and that is really frustrating.
It's really frustrating, and you have.
What can you do about that?
Well, you just if the customer says that's it, these are the requirements. I don't want to argue anymore about it. You got two choices. You will build it exactly as the customer stated, deliver it exactly what the customer said in the requirements, and then negotiate all the change requests for which you will make a small fortune.
Exactly.
The other option, if you're true level 5, and it's a real disaster, and you can see this isn't going to work, it's going to be a nightmare, they'll be mad in a year and a half. Just say, gentlemen, we want you to go to one of our competitors and see what they'll say. We're happy to let this business go to a competitor, and you just back away from it. Because if you're a true high maturity organization, you're not going to have to worry about business because people want you because you're reliable and you're less expensive, and you can walk away from contracts are going to be disasters. If I had been a manager, that the people that did Obamacare claimed to be level 5, clearly they weren't. But if I were the manager in a level 5, I would have walked away from that contract. So if you are not, you will not have started by this time, we will back away because you can't test this thing, and we cannot guarantee it's going to work with 2 weeks at the end of the process to test this massive system. It's just you need to find someone who thinks they can do that. We know we can't, and if you're a high maturity organization, you have a tremendous power to negotiate because you have a record of having succeeded and delivered on time, on schedule, high quality systems, and we know we are the professionals. We know what it takes, and if you want to do it in half the time, be my guest, but not us.
Yeah, I wonder. I mean, I now these days I only work for small and medium-sized companies because with these, the leaders are mostly also the owners of the company. Yeah. They really care. So if you explain that to them, everything we did here, we forgot stuff, we didn't know it, then they're like, okay, there is one person above everything which is responsible, and one said everything will be good. So I can go to these people.
So
but if I go to a large, 50,000 people company, it somehow gets lost.
Look, here's the thing. Unless if they're immature, yes. If they're immature, yes. If they're mature, much more mature, not necessarily. But the biggest problem you got in a small company, especially a real small company, is that especially if they put out an IPO, right, and they have public ownership, or they've got money from venture capitalists, how many of those CEOs actually last more than 3 years or even 2 years? The problem is they know how to get something started, but they don't know how to get it to the next level of development. They don't know the processes and disciplines and all these things. And so you see these guys get the thing started, and it's a massive success, but they don't know how to take it to the next level. They don't know how to scale it because they've never had to manage in that. And so they take that founder out and put a more experienced manager in. That happens all the time. And it's exactly what happens in process improvement. You find middle managers and project managers that really just can't move in this direction. They just can't bring in the discipline required, and you can't scale a business without it. And that was the fundamental lesson in Good to Great and Built to Last, was you have to have a disciplined process in order to be able to scale it. The Toyota production method, right? The quality system and the concepts from which Lean came, start out with the premise you have a standard process. If you don't, we can't improve a non-stick. It's an adjustment to every little thing, and Deming's already said, then you're nowhere.
Yeah, right? Exactly. No, I heard that from David Anderson, the guy.
David Anderson, yeah.
So he got asked for, introduce Kanban to my organization, and he was like, I can't. I mean, if you don't have a process already, I cannot do that.
Yeah.
If you have a process, I can come with my Kanban, and then we can improve the way you work.
Exactly.
But if everything is still a chaos, we first have to introduce something.
One of the fundamental concepts in Kanban is it's a way to manage the amount of work you're taking on, because you can't add it in if there's not a slot for it.
Exactly.
Right?
Yeah.
It is a disciplined way to control commitments and to learn how much you can actually get done, because you got lots of blocking things if you're kind of screwing around. So it's a very good it's a good process worth looking at. Okay,
I see we already have more than 1 hour. So just to wrap it up, so important for software quality is
you must measure, you must control commitments, you must control the baselines, and your managers have to back the developers. They really have to provide an environment in which developers can work in a professional way, because the developers really want to produce excellent stuff. They're proud of their work, and if they're thrown into an environment where they can't work in a professional way, where they've got commitments they can't possibly meet without being nights and weekends and all this, eventually they'll get fed up and leave. And so controlling commitments and baselines, measuring is critical. Ultimately, at the organizational level, getting to an organizational way of doing it and a cultural build around that. And it'll be quite something. And then the defect rates go way down, and it becomes much cheaper to produce software. You're getting stuff out much faster, and the business, because that's better software, the business becomes more agile. Why? Because you can make changes much more quickly. Exactly. The business agility is strictly limited by the quality of the code, because if it's hard as heck to make changes that the business needs to compete, they're going to be behind their competitors. So measure, have a discipline, put discipline in place. Management's responsible for providing that environment so that the developers can use a professional process.
Okay, and software architecture. Get the architecture
get
right,
the architecture straight, or you will pay a huge price, and that price may be death.
You cannot put.
You can't refactor a cruddy archecture on an important system.
In the end, it's impossible to put safety.
Yeah, and what you can do is just stop and typically start over.
Okay.
And just rip and burn.
Good.
Thank you,
Bill. Thank you for being on the show.
My pleasure.
This is Sven Johann for Software Engineering Radio.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more information about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can write comments on each episode on the website or write a review on iTunes. Mention or message us on Twitter at SE Radio, or search for the Software Engineering Radio group on LinkedIn, Google+, or Facebook. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under the Creative Commons 2.5 license. Thanks again for your support.